Right, in this section we're going to explore graphing straight lines. Now we're obviously in a section called linear relations, so we're looking at lines, and we've been looking at linear expressions and linear equations, and we looked at what makes something linear, and we talked about it being a power of 1, so the highest power of x is 1. So graphing straight lines, I want to start with something like, let's just start with, right, let's look at y equals 2x plus 1. I just want to, this is what we're going to examine. Y equals 2x plus 1. We're going to look at how we go about graphing that, what that's going to look like. So I've put together a little set of axes here. It's a number plane, it's a Cartesian plane, it's a set of x-y axes. Right, x along the horizontal and y along the vertical. You know that we've got a whole bunch of coordinates, don't we, on this in this field. What we're going to do is we're going to plot the coordinates that satisfy this equation. Right, we're going to plot the points that lie on this line. Now, and I know it's a line because it's got power 1. It's linear. If it was power 2, it'd be something else. It'd be curved. It'd be a parabola. This is linear. Right, everything's power 1. But what we're going to do is, it doesn't even matter if we know that, because what I'm going to do straight up is go back to basics, and we're going to set up a table of values, a table of points that we know lie on this line. So I'm sure you've done this before, where you just go and find some points, so that satisfy this equation here, because this is the rule that we're following. Okay, so what we do typically is we have a look at, we have a look at a few points, don't we? We put -1 down, we put 0 down, 1, 2, something like that, and we get a little feel for this. So what we're going to do now is we're going to find out the y coordinates for each of these x coordinates on this line. So this is how we do it. We put x equals -1 in initially. These are the x values across the top row, and the y values down here are going to be the corresponding y points on this line. So when x is -1, you put -1 in here. 2 times -1, calculate that is -2 plus 1. What do we got? -2 plus 1, it's -1. Alright, so I'm just going to put that there, and I'm going to actually, while I'm at it, I'm going to go right to that point, -1, -1, and put the point down there. Right, there it is. Now I'm going to go to 0. Put x equals 0 in here. 2 times 0 is 0, plus 1 is 1. So when x is 0, y is 1, so that's that point there. Alright, so I've got 2 points now here, -1, -1, and here at 0, 1. Okay, so the next thing we do is put 1 in for x, so 2 times 1 is 2, plus 1 is 3, so y equals 3 when x is 1. So I'll put 3 in there. I go to my 0.13, so how do I do that? I go to 1 on x, which is 1 across, and 1, 2, 3 up. There we go. And if I'm doing this right, they should all lie in a straight line, which they do. Let's just check with 2. When we put x equals 2 in here, we get 2 times 2 is 4, plus 1 is 5, so y is 5. So when x is 2, 1, 2, 1, 2, 3, 4, 5 is our point, and look at that, line, a straight line. That's beautiful. So now what we do is we draw a line through those points. We don't just stop at those points, so we go either side. Now just excuse my freehand drawing. You'll have rulers and do a better job than me. But that's our line. See, notice what I've done there is I've drawn right through the 5. I've just used that as a guide, right through, and drawn arrows on the end of each. Now why do you think I put arrows on the end of each? Because this line goes on forever in both directions. There's no limit to our values of x in a positive or negative direction. It goes on to infinity. So there's our line, and I drew it just by going and looking at some points that satisfied this equation. When I say satisfied, that work. When x is 2, y is 5, that works. Let's find a point that's not on the line. Let's go to a point, that point there is not on the line, 1, 1. Now let's just show that it's not on the line. 1 for y, 2 times 1 is 2 for, so x is 1, 2 times 1 is 2, plus 1. Is 1 equal to 3? No, it is not. It is not equal to. That's rubbish. That point doesn't lie on that line. But all these points here, they do. They do satisfy that equation, and they do lie on the line. Okay, so there's some basics there, aren't there? Now, what you probably already know is the gradient intercept form of a line. I'll just pause this and make a couple of notes on that. So the gradient intercept form is, and you might recognize this, y equals mx plus c. So when the equation is written in that form there, where y is a subject, y equals something x plus c, that's called gradient intercept form because that m there represents the gradient of the line, doesn't it? The gradient. And the c there represents the y-intercept. Okay, so let's go back up here. This is in that format, isn't it? This is in that gradient intercept form, y equals. So here, that's telling us that the gradient equals 2, isn't it? Alright, so we'll check that in a moment. And this 1 here is saying that the y-intercept of this line is equal to 1. Let's go and check here. Is the gradient equal to 2? Now, how do we know about the gradient? The gradient is rise over run, isn't it? So we take any section of our line and we measure the rise, which in this case is 1, 2, over the run, which is 1. So our gradient here is equal to rise over run, which is equal to 2 over 1, which equals 2, which matches our 2 in front of the x there. And the y-intercept, here they're suggesting is 1. Well, yeah, of course it is. Look at this. Where does it cross the y-axis? At 1. So this matches our knowledge. So what we could have done, in fact, is we could have, if I just get my little xy axis set up here, there we go. What we could have done was for y equals 2x plus 1, I could have said, oh look, it's in gradient intercept form. My y-intercept is 1. The first place you go to is your y-intercept because that sort of anchors it. My y-intercept is 1. It's just sort of not on a thing, but that's alright. So I put a point down at 1 because I know that this line will go through 1 on the y-axis. Now the gradient's 2, so what that tells me is my rise over run is 2 over 1. So my rise, 1, 2, so I go up 2, and I go to the right 1 because it's positive. If it was negative 2, I go to the left by 1 because this way is a positive slope. It's a positive slope. Going this way is a negative slope. So if it was minus 2, I'd go up 2 and across to the left 1. Okay, so I could have done that. There we go. It's the same graph. It's quicker than doing all these points. We use the gradient intercept form to sketch it. Okay, so that's what we've got there, gradient intercept form. Going to have a look at another format now. I'll just get the heading down. Okay, so the second method we're looking at here is sketching using the x and y intercepts. I'll explain what that means in a second, and we're going to use this example here. Okay, so in this method we're going to find 2 points. We're going to find the points where this line intercepts with the y-axis here and on the x-axis here. We're going to find those points. Firstly, we need to understand something. We need to understand that we find the x-intercept. We find out where a line hits the x-intercept by making y equal to 0. So we'll look here on the x-intercept. On the x-axis, the value of y is 0, isn't it? All the way along here. And so we find the x-intercept by making or letting y equal to 0. Alright, so that's that. And conversely, we find the y-intercept here, the y-intercept where the line crosses the y-axis, where x equals 0. So I'll pause while I write this. Okay, I've just made that note there. We find the y-intercept by making x equal to 0. So we find these 2 points. So therefore, let's go now and work out these 2 values. So here's my equation here. 3x plus 2y equals minus 6. We find the x-intercept by making y equal to 0. So now firstly, we're going to find the x-intercept, and we let y equals 0. Okay, so we make y equal to 0, so it's 3x plus 0, make 2y, when y is 0, that's 0, equals minus 6. So what we end up with is 3x equals minus 6, x equals minus 2, if you work that through algebraically. So what that means is we're heading over here to minus 2, that's our x-intercept right there. That's our x-intercept. We make y equal to 0 in this equation. Okay, now let's do the same for the y-intercept. So for the y-intercept, we're going to let x equal to 0, and that means our first term here is 0. I don't need to write that down. I will just for effect. 0 plus 2y equals minus 6. So 2y is equal to minus 6. Y is equal to minus 3. So we take our marker down here to 1, 2, minus 3, and that's my y-intercept. And that's all I do. So I find my x-intercept, my y-intercept, I put those markers down, and then all I do is now draw a line connecting those two intercepts and also extending through and putting arrows on the end. So that is the equation, that is the line that satisfies this equation here, 3x plus 2y equals minus 6. And I've drawn it using 2 points only, 2 points where the line hits the x and y axis. Now the reason we use those 2 points is because it's really, isn't it nice if you make y equal to 0, it just dissolves this whole term. So we're just solving a very simple equation. And the same over here, when we let x equal to 0, we just solve for y quite simply. We can get those 2 points and we're away. Now it's this, when the line is in this format, when the equation is in this format, it's a really good idea to use the x and y-intercept method. When it's in this format, right, when the equation you're given is in this format, that's gradient intercept form. So it's probably a good idea in this case to use what we know about the y-intercept and the gradient to draw your line. Okay, we're just going to have a look now at lines that only have one intercept, and I'll just pause for a moment. Right, let's take a quick look now at lines that only have one intercept. So what that means is these poor fellas are not cutting through both the x and y axis, they're only going through one or the other. So let's start with this one here. If there's any angle on this whatsoever, that's a vertical line. That's parallel to the y-axis. If there's any angle on that whatsoever, so what I mean by that is if this deviates off this vertical, then it's going to cut through the y-axis, isn't it? It's going to way up here maybe, or way down here. Excuse me, but it's going to make that intercept. So this is a vertical line. It's a vertical line, and when you've got a vertical line, it's got an equation. X equals. Have a look at this. This is x equals 2. Look, what is the x coordinate at every point on this line? What is it? What's the x coordinate? It's 2. So the equation of the line is x equals 2. That is it. That defines the line. Every point on that line has an x coordinate of 2. Now if we take that same logic and apply it here to this type of line that only makes one intercept, show arrows on that purple one, then we've got some arrows, then we've got a line here that goes through 1, 2, minus 3 on the x-axis. What is the equation of that? The horizontal. It's a horizontal line again. If there's any angle on it whatsoever, if it's not flat, it's not horizontal, it'll cut through the x-axis. There'll be 2 intercepts. We want only 1. It's a horizontal line. What's its equation? Any horizontal line has equation y equals, because if you think about it, same logic as before, every y coordinate on that orange line is equal to minus 3. So horizontal line, y equals minus 3, horizontal line, x equals 2, 1, minus 0, minus 0, 0, minus 1, whatever, x equals something, it's going to be vertical. The only other type of line that has only one intercept will be this guy here that goes through the origin, like that or like this. That doesn't have, so if you think about that in intercept form, gradient intercept form, it's got a gradient, y equals mx, but c, my y-intercept is 0, so it's not going to have a plus c, so it's going to be y equals something x. That's going to go through the origin. That's only got one intercept also. Okay, that's enough for this YouTube. That's more than enough. Exercise 1E awaits. I'll see you in class and we'll tackle that.